In multiband dynamics processing, we split the wideband signal to discrete bands. Each band is sent to its dedicated dynamics processor and then is applied its desired dynamic gain adjustment. Splitting the signal has several major advantages. First, it eliminates intermodulations between adjacent bands. Second, it eliminates gain riding between different frequency bands. Third, it allows you to set each band's attack and release times scale to the frequencies in that specific band. And then lastly, it allows setting different functionality, for instance, compression on one, expansion on another, equalization on another, per band. For example, it's possible to compress low frequencies with longer attack release values on one band, while at the same time expand the mid-range frequency with shorter ones, and simultaneously DS high mids with much faster attack and release times, and boost the super high frequencies with no dynamics whatsoever. It's a very, very flexible tool. Let's take a look at its controls. The individual band controls have threshold, which defines the point of reference for that band's energy. Whenever the energy in a certain band exceeds the threshold, gain adjustment will be applied. Gain sets the overall output gain of the band or the band's makeup value. Range sets the possible range of dynamic gain adjustment and also its intensity, replacing the classic ratio control that we're used to and adding a firm boundary to it. Negative range means when the energy exceeds the threshold, gain reduction will be applied, while positive range means boosting the signal further. The attack defines the time it will take to apply the gain reduction from the moment the detected energy exceeds the threshold. Release defines the time it will take to release the applied gain adjustment from the moment the detected energy falls below the threshold. Solo allows the band to be isolated to the main processor output. You can also group solo, meaning choose more than one solo per band. When you engage bypass, all processing on the band will be terminated and input will be routed to output. There are 4 crossovers in linear multiband. Each sets the cutoff frequency for the high-pass and low-pass filters that cross each other. Each of the 4 crossovers has a unique range of frequencies. Your low crossover options are from 40 Hz to 350 Hz. The low mid option, 150 to 3000 Hz. Selection for high mid, 1000 Hz to 8000 Hz. And lastly, selection for high would be 4000 Hz to 16,000 Hz. The output section contains several controls. Gain sets the overall output gain. When you click on the auto trim button, it updates the peak value and adjusts the output gain control to trim the margin so the peak will equal the full digital scale. Dither, the double precision 48-bit processor can handle overflows. The result, however, comes out of 24-bit back to the host's application audio bus. Some native hosts may output 32-bit floating point outputs to the mixer or to the next plugin in line. It's in this case that it's highly recommended not to use dither, because the dither control will add dithering back to the 24th bit rather than just rounding it off, which would be the case when dither is off. The dither's noise and suspected quantization noise when no dither is used are extremely low. The global behavior settings will apply global dynamics processing behavior, which will influence the per-band compression properties. The adaptive control sets the sensitivity of the band. As far as release, there are 2 options: ARC, or auto release control, or manual. The auto release control sets an optimal release time in relation to the material release time. The manual release is selected when the release of the attenuation will be absolute as indicated. By adding automatic release control, it will make the release sensitive to the amount of attenuation and set the best release time to get the more transparent results. There are 2 different behavior settings: opto or electro. Opto is classic modeling of the opto-coupled compressors which use light-sensitive resistors to control the amount of compression in the detector circuit. Basically, opto mode has fast release times at high gain reduction, slow release times as it approaches zero gain reduction. This can be very beneficial for deeper compression applications. Basically, the electro mode has slow release times at high gain reduction and progressively faster release as it approaches zero gain reduction. This has a very good benefit for moderate compression applications where maximum average level and density is desired. The knee control affects all 4 bands' knee characteristics, ranging from softer, low values, to harder, higher values. At the maximum value, the master knee control tends to give the sound a harder edge, with a punchier overshoot style character. Adjust this to taste. The knee and range together interact to kind of give the equivalent of ratio control. Remember, to achieve limiter type behavior, use high knee settings. Lastly, the displays. The multiband graph is like an EQ graph showing amplitude on Y and frequency on the X-axis. The output meters show the master output of the processor. The band threshold meters show the input energy in that band. Under the meter is a peak hold numeric indicator. When you want to set your thresholds, you can use the peak as a reference and then continue to tweak it a bit with the master threshold control.